This video will provide a brief introduction to the periodic table, which is a very helpful resource for all chemistry students. So first of all, what is the periodic table? Well, it's basically just an organizational chart. And what it's organizing are the elements, the different kinds of atoms that make up all of matter. The periodic table is organized based on the chemical properties of those elements. And of course, chemical properties is all about how an element reacts with other elements. And in a chemical reaction, you have atoms and molecules changing in some way, because we only see chemical properties when we've had a chemical reaction, which means we've got a chemical change going on. The periodic table is organized furthermore into things called groups and periods. Elements that have similar chemical properties are arranged in groups, and those are 18 vertical columns. But then you have repeating patterns of chemical properties, which then create the periods, which is just another way of organizing the rows. So we have 7 horizontal rows or 7 periods. These patterns of chemical properties, by the way, are due to how the electrons are arranged around the nucleus in the atom, how many there are in the outermost level, and if they can change levels at all in some of the more complicated atoms. And so that gives us particular patterns, and we'll talk more about that as we go on in this class. Elements are also organized in the periodic table in order of atomic number. So from left to right, we go from the lowest number 1, of course a logical starting place, to the highest number, which right now is 118. On the periodic table, we find a lot of helpful information. The first piece that we'll just start with today, you'll get more as we move forward in this course, but I want to first talk about the atomic symbol, or the abbreviation of the name of the element. You've been working with some of these atomic symbols already in biology. You're familiar with oxygen and hydrogen, of course, if for writing the formula for water, H2O, or carbon, C, nitrogen, N. Those are all ones that we talked about last year. So a single capital letter can be used as an atomic symbol to represent an element's name. But we also have some names that are 2 letters, one that is capital and one that is small. So we have Na for sodium, Cl for chlorine, Fe for iron. Elements that have been known since ancient times have Latin-based names, which is why we have Na for sodium instead of something more logical like involving an S. Our modern element names are English-based and sometimes actually are connected to a particular person, such as Einstein, or a location, such as Poland or America. Other information that we will get to is the atomic number. So said they are numbered from 1 up to 118. And also the atomic weight or atomic mass is another piece of information that you'll be working with quite a bit as we go on in this course. So the periodic table, furthermore, can be divided into 3 broad categories of elements. And we can see the 3 colors here on this slide. So metals are one category of element in the blue color. And then we have nonmetals, they're opposite over there in green. And then in between we have metalloids, or sometimes they're called semi-metals. So these different elements are not only organized in columns and in rows or in periods, but you also can kind of see that there's a split through the table where the metalloids kind of provide a dividing line between the nonmetals on the right and the metals on the left. The only weirdo is hydrogen, number 1, who is placed over here on the far left in a column with other metals, but it actually, you can see from the color, is a nonmetal. So within these 3 broad categories, the groups themselves can sometimes have special names and consist of areas that are more than 1 column. So if you look at this color-coded diagram, we've got this big section in the middle that is all yellow, and those are our transition metals, as we can see down here on the code on the bottom. Some of the other groups that I will talk about quite a bit are our noble gases here on the far right, and then also right next to them the halogens, things like fluorine and chlorine, bromine, iodine. So as we go through the periodic table, sometimes we refer to the elements in terms of metals or nonmetals, or sometimes we're talking about particular groups, like say the alkali metals over here on the far left. So let's talk generally about the characteristics of these three broad categories. You'll see in these characteristics things that you learned when we were talking about properties of matter just a few weeks ago. About 80% of all the elements are metals. So you can remember that table had a lot of blue in it. And metals, as you already know, are good conductors of heat and electricity. They are malleable. They can be hammered into thin sheets. They are ductile or have ductility. You can pull them into wires. They typically are shiny. They have luster. And they are all solid at room temperature except for mercury, which used to be used in thermometers because it was a liquid. Nonmetals, moving over to the far right-hand side of the periodic table, are basically the opposite of metals. They are poor conductors of heat and electricity, and unlike metals that, as I said, are just solids except for mercury, we can find them in all three states at ordinary room temperature, though many of them are gases. Oxygen, hydrogen, nitrogen are all gases that we're very familiar with, and they are nonmetals. Nonmetals that are solid are brittle. You can't make them into a thin sheet or a foil. You can't pull them into a wire. They are not shiny. They are not lustrous. And they have lower melting points than metals, which is why they are going to be liquids or gases. Bromine is a liquid nonmetal. Most are either gases or solids, but many of them are gases. And then we get to the in-between, the metalloids. Metalloids look like metals, but they behave more like nonmetals, and they're sort of the dividing line between the two categories. Typically, metalloids have luster, so they are shiny, but they are brittle, which is more like a nonmetal. They can conduct electricity, but not so much as metals can do, and because of the way they conduct electricity, they have become very important in our electronic world. I don't know where computers would be without silicon, which is one of those nonmetals. So this gives you an overview of just sort of the periodic table, how it is put together. As we work with it this year, you'll become much more familiar with these different parts of it and where you can find the different elements on the periodic table. But this was just an introduction to get you started.